at inclusive inequalities. In our previous class, we've discussed exclusive inequalities, and I said exclusive inequalities are open inequalities, meaning that the number you have in that inequality is not a member of the set of that particular variable you're dealing with. And I gave you example like x greater than 4. I said 4 is not a member of x. So the first number you write for x will be 5, not 4, because 4 is not a member of x. Now, for inclusive inequality, you see it having equal to sign attached to it. So it will be in this form. So we have x is greater or equal to 4. X is greater or equal to 4. This is the equality sign that is beneath here. X is greater or equal to 4. That is inclusive inequality. It shows that 4 is a member of the set of x. So x is greater than 4 and also equal to 4. So x will start from 4 since it's equal to 4. So this type of inequality is referred to as inclusive inequality. So the numbers of x will be from 4, 5, 6 upward to any place you're asked to stop. But this is what inclusive inequality is all about. And the inequality line graph is always closed because the number is a member of that set. So I'm going to shade it. That shows that the inequality is inclusive. The other class was open. In the other examples of the previous class was open, but now it is shaded, meaning that 4 is a member of this set. So we have here our 4 and we have our x, the arrow going this way because it is greater or equal to. Now when you have x is less than or equal to minus 2. Now x is less than or equal to minus 2 shows that minus 2 is a member of the set of x. So in that case, the line will also be closed. You can see that closed. Write your minus 2, write your x, and bring back the arrow because less than is always coming back, like I said in the previous class. So these are what we refer to as the inclusive inequality. Now, how do we apply this exclusive inequality and inclusive inequality in our quadratic problem? Now, if we are given the limit, for instance, we are asked to get this equation solved, 2x squared plus 4x minus 3 is equal to 0, for which x is less than 4, greater or equal to minus 4. X is less than 4 and also greater or equal to minus 4. Now you can see that the two inequalities have been applied here. One part is exclusive, the other part is inclusive. X is less than 4 is exclusive because 4 is not a member of x. It's not going to be a member of x. X is greater or equal to minus 4. Minus 4 is going to be a member of x because this part is inclusive and this other part is exclusive. So what will be the values of x? Because we said we need to understand the limit of x to help us get the values of y. So I'll be having the limit of x in this form. Minus 4 because minus 4 is a member. Minus 3. Minus 2. Minus 1. 0. 1. 2 and 3. I will not write 4. Why? Because 4 is not a member of this particular set. Because it is x less than 4. X is greater or equal to minus 4. So if you understand how to interpret your inequality properly, then you will be able to solve your quadratic problems properly. I'm going to show us in our next class how we are going to be having control of the independent variable from the inequality standard given to us to help us get the values of y. So see you in our next class.